Thank you so much. It's a great pleasure. Thanks for being here. We're going to talk about the excitement around good old Java. But before we go, I just want to spend just a couple of minutes talking about, you probably see my name, and one of the things that absolutely bothers me is, if you really think about Java, and I was thinking, what is Java? And somebody asked me, what's Java? And my answer to them was, truly, Java is the passport to the world. And I say that Java is a passport to the world because Java as a language, has really enabled me to travel to so many countries around the world, meet so many exciting people. I can't tell you how many times I'm in a random city, in a train or a bus, and suddenly somebody comes up and says, hey, and then we sit down and talk about Java for an hour or 2 hours, waiting for the next transportation and so on. And then one of those things that really helped me was to get to know some amazing people in different parts of the world, and that really meant that I actually got to spend some time in Ukraine. And I've been to Kyiv and to various other parts of Ukraine, and it absolutely disturbs me to know what is going on over there. So I just want to first of all express my support for all the friends and all the people who are going through such a suffering right now due to the insanity that we are facing. And I hope, truly hope, that this all comes to an end for the better. And just a couple of weeks ago, the DevOps Ukraine conference, they put up a charity event for collecting money for the cause of Ukraine, obviously, and which also, once again, absolutely blows my mind. I always think about how would I react when things really go bad, and I'm almost in tears to say this. And for these people who are being attacked right now, to have the courage to put up a conference in the time, what a positive attitude to deal with this. And just absolutely blows my mind. So my heart and my thoughts are with people over there, and I'm really hoping that things get better for them soon. And in any way we can support, I think we should really do. So I want to talk about Java in today's world, and then how Java is today compared to years ago. But I want to start with this word that we all talk about quite a bit, about agile development. So thinking about agile development, we all work in various companies. We are all, I'm sure, part of certain agile projects that we are all working towards, an agile initiative. So what is really about agile development? I'm going to start with 2 words that I really hate the most. I'll get that out of my system to begin with. And then I go to companies, and the first thing they want to tell me is, Venkat, we want you to know we are agile. And I always tell them, I'm so glad we got that out of the way. Now let's talk about what you do. But there are 2 words that absolutely bother me in development today. And the first word, maybe a set of words, is Scrum Master. I have no clue how this actually happened or why. This was never supposed to be a job. This was never supposed to be a role. And now I come across people who say, what are you? I'm a Scrum Master. I'm like, I'm sorry. That's all I tell them. I actually had a session a couple of weeks ago where there was room full of Scrum Masters, and that's exactly what I told them. And they are like, oops, so I'm sorry. I'm not personally insulting anyone, but I think this was never meant to be. This was never meant to be a job or a title or a position. And so, in effect, this is one of the things that really surprises me. We as humans love rituals. The reason we love rituals is rituals give us relief from reality. We don't have to do the real work anymore. We can practice this ritual. We can have a stand-up meeting. That's so much better than actually getting the real work done, isn't it? So the point is, we tend to really hide behind rituals because it gives us that relief from what we actually have to do. And I don't understand still this role of a Scrum Master because this was never meant to be. The first thing that you see in the Agile Manifesto is people over process. And what are we doing now? We're creating process over process over process. That doesn't make sense. The other thing that absolutely makes no sense to me is this other word called velocity. And I don't know why, again. If you want me to be on a project, and if I show you speed in the beginning, you should be worried, not celebrate. Because if I give you speed in the beginning, what that tells you is, I'm doing easy things, I'm not putting enough time into quality, I'm just trying to impress you, and you don't want me to impress you. You want me to deliver the results for you. And so if I'm really fast in the beginning, I'm going to come to a grinding halt when it really matters as we progress on the project. So it's a very misplaced focus again on companies when they focus on velocity. So I once tweeted this. It took me all these years to realize TDD stands for ticket-driven development. Thus, many organizations actually practice it. And this is one thing we commonly see is these practices that we drive towards that we're not really meant to be, but we get really excited about these things. So let me ask the question, what is really then agile development? And I'll tie this back to why I'm talking about this in a few minutes. What's really agile development? And I'll say agile development really is feedback-driven development. That's what it really comes down to. You want to drive your development based on the active feedback of what you're creating. And a feedback gives you the ability to know if you're heading in the right direction, if you're meeting the customer's expectations, and if it's not what you need to be delivering, you want to alter it. And we as humans are driven by feedback. This is amazing. This is in our DNA, and yet we reject it so much when it comes to developing software. When I walk, I'm able to walk steadily because my brain uses the feedback from me walking. If I blindfold myself and try to walk the stage, I'll bounce across the wall or fall down because I don't have that feedback loop. We rely on that feedback heavily as humans. And I remember this was back in 1993. I was on the very first trip to Grand Canyon. Beautiful place. I've been there several times, and I'm hoping I'll be there again. But this was about 30 years ago, my first trip to Grand Canyon. And I started driving from Phoenix. And I was on the car for about 2 hours. And all of a sudden, my question was, am I going in the right direction? Because Grand Canyon is not a mountain. It's a hole on the ground. You can see it from afar. And so, am I in the right direction? And remember, 1993, this was time before GPS and all the other wonderful technologies and smartphone. And I pulled over by the side of the road, and I was thinking, what should I do? I got two options on my hand. I can turn around, make a U-turn, drive for an hour until I get to the civilization and say, excuse me, was I going on the right direction? And they say, yes, you are, and I'll make the trip back again an hour. Or I can keep going in the direction I'm going, not knowing if I will ever get there. And you say, oh, Venkat, didn't you have a map on your hand? That would have helped, isn't it? Oh, sure, I had a map on my hand. But there was one thing that was missing on the map. You know what that is, right? That blue circle. And the blue circle did not tell me where I was. So the map said where everything is, but it never told me where I am. To me, that is agile development, where I know where I am, and not how far I've come so far, but how far do I need to go to get to where I need to be. And that kind of feedback is what we thrive upon. Today, I just don't care about much. I get in the car, start driving. Oh, that was the wrong direction. Make a U-turn, and I can go now because the GPS is tracking most of the time. The other day, I was using Google Maps. It said turn left. I ignored it. It said turn around and turn right. I ignored it. It said no, turn around again and turn left. It wanted me to go on the railway track. I'm like, good try, no. I'm not going to do that. Most of the time, the feedback loop is really good, but we still have to pay attention to it. But that feedback-driven development can be really amazing if only we can use it. But let's talk about Java. Java as a language, can you imagine any language that's done this in the history? Let me rephrase it. Can you think of any good language? Because when I say that, people say JavaScript, so I always rephrase it. Can you think of any good language in history that's done this, where it's been popular for 27, 28 years? That's never happened in human history. Programming languages were popular for about 10 years. Sure, they're used for a long time. I'm sure you will dig up somebody who is still working on COBOL, right? As much as C++. But for a language to be popular this long, there's only two languages I think that's done this so far, Java and JavaScript. But of the languages, the power, amazing capability of the ecosystem of the JVM is just amazing. But I'll be absolutely honest with you. If you switch back to about 2007 timeframe, I was that person on the other side of the picket line, constantly screaming that Java is not moving, Java is stagnant, I hate Java. And I'm not kidding with you, I've saved these emails for history purpose. I've used to get emails from people that started saying, Venkat, I hate you because you hate Java. Because apparently it was wrong to hate Java back in time, maybe even today. And I really did not favor Java. I would complain about it. And the reason I did was the language was very stagnant. It did not go anywhere at the time, and I would be vocal about it. And of course, as time went on, I realized that that snail-paced development was not going to help at all. And I was worried, this language is going to die. And it was, time to sing the last rites of this language. And then all of a sudden, when Java 8 came out, the one language that was on the deathbed was jogging and having parties and celebrating. And you look at this and say, whoa, what just happened here? A language that was supposed to have died really came back to an amazing power. But the reason for that, of course, is the innovation that went into Java. Now, clearly, I often say jokingly, when I talk about Lambda expressions and the functional programming, we clearly know functional programming has been around for a long time. Java was not the language that created it. But Java, of course, came with some interesting characteristics in it. The amazing power of invoke dynamic, which made really the implementation of lambdas very powerful and efficient in the language. So jokingly, I often say that Java came very late to the party, but it came with some amazing desserts, and that made all the difference in terms of their late arrival into it. But that definitely changed where Java was going to head, and looking at it, it's amazing to see how that development went along. But if you look at the timeline, it's very interesting to watch it. If you notice, the Java 1.0 was released in 1996. Then came in 1997, 1.1. Hey, that's a 1 year. That's awesome. 1.2, 1 year later, 98. In 2000, 2 years later, 1.3. What happened to 1.4, 2 years later? 1.5, 2 years later. And Java 5. And Java 5 was the biggest release of Java since Java 1 at that time. We had things like generics and auto-boxing and a few other things exciting. But that was Java 5. Then 2 years later, Java 6. And many of you may remember, Java 6 had no language features 2 years later. And then what happened? Java 7 was nearly 5 years later. And you may remember, at the time they were debating, do we release Java 7 with lambdas, but delay it by another few years? Or should we release Java 7 now without lambdas? And there was a lot of debate about it. And of course, as history shows it, they released Java 7 without lambdas back then. But then 3 years later, came along Java 8. Now you may say, wait a second, these were 1 year releases away, but these were 3 and 4 years apart. What just happened? You and I know this exactly what happened, right? Because they are much like us. When your boss comes to you and says, how's it going? What do you say? I'm almost done. And that I'm almost done usually means 3 years or 4 years. And this was the biggest mistake that they did, is to tell what should be in a release of Java before we actually get down to implementing it. And we all know what that's called, waterfall. And we plan on what we want to release, then start working on it. And when we do, now you have like 3 or 4 features you want to release, hey, how's it going? I'm almost done. Okay, let's wait for them to finish. We'll release it with it. And now we are trying to synchronize all of these things. And by the time a feature is released, the person who wrote it doesn't even remember it. And the time has gone so far. And when people start adopting it, it is so many years after it was implemented. That's a very slow cycle. What good is a feature if you implement it if nobody gets a chance to use it? So this was the place where we were a few years ago. And as you can see, Java 9 was again 3 years later. And at this time, the folks behind the language realized this is not going to help us. And they took a very bold decision. I call it bold because it was not easy for them. It was not received with open arms. And they took a very bold step to accelerate the pace of development of Java. And at that time, of course, they announced that we're going to have a release every 6 months. Now, if you notice over here, Java 10 was in 2018, March, and then a September and a March and a September, March and a September, March and a September, like clockwork. There's a release every 6 months. Now, you may look at that and say, whoa, that's a 6 months release cycle. And when you ask people what do they think about it, there was a lot of skepticism. Nobody believed this would work. And I really want to emphasize about the 6 months release cycle. And that is, make note, Java is not being developed on a 6 month cycle. It's very naive to think that the features that go into the language can be cooked up in a 6 month cycle. These are very complex details that get developed. It takes time to think through them, to design them, to implement them, and to really get them working. For example, take one feature in Java 10, which is a local variable type inference. That feature took them 5 years to implement. Take the feature that we are seeing in Java 19 as a pre-release, Project Loom. That's taken them 12 years to implement. These were not implemented in 6 month cycle. It's naive to think that they're developing this in 6 months. So some people are worried. They say, oh my gosh, if they're doing this in 6 months, what about quality? What about... No, they're not developing this in 6 months. Java is not going through a 6 months cycle for development. But a few years ago, this was back in the year 2018, the year I was turning 50 years. And as I was turning 50 years, I was on a train ride between Krakow and Thoren. And I was on the train and thinking what I want to do, and suddenly a thought occurred to me. Hey, what if this is my 50th year of birthday? What if I go to speak in 50 user groups? Wouldn't that be awesome? And immediately I texted my wife, who was just about waking up here in Colorado, hoping she would say, you madman, get out of the train and come back home. But instead she replied, what a great idea. And the next thing you know, I dropped an email to one of the user group leaders, and they said, we love the idea, let's do it. And all of a sudden, I blogged about it, and within a matter of days, I had most of the 50 user groups signed up. My 50th user group actually was coinciding with the 25th anniversary of the Paris Java user group, and this was on the top of the Eiffel Tower, where I gave my 50th talk that year in the 50th user group. So it's an amazing experience to be able to speak in all these user groups. But more notably, one user group visit was a visit where I spoke in 6 user groups in 1 week, pretty much one night a week except for Sunday, I think. And I was supposed to land in Zurich, speak in Zurich, and then Lucerne, and then back in Bern, and so on. And then I was going to hop into a train and go to Germany and speak there as well. And I was thinking, one user group per night and across 6 different cities, I don't know how it's going to work. And I land in Zurich, and Marcus is the user group leader of the Switzerland user group. And Marcus meets me in the airport. And Marcus is such a calming, fatherly figure. If you ever meet him, you will just absolutely feel comfortable. I just spent a week with him 2 weeks ago, once again. But I just absolutely love his company. And he picks me up at the airport and hands me a folder and says, here you go. I said, what is this, Marcus? And he said, this is your train tickets. And this train will take you across Switzerland, any city you want to go to. And I bought these tickets for you. And he said, the train leaves at 10 past the hour, and it leaves at 40 past the hour. And you can take any train you want to. You can take the train at 9:10 or 9:40 or 10:10 or 10:40. You can go on any train you want to. And I would wake up in the morning, I would do some work, I would jog, I would exercise, I would have some nice breakfast, and I would say, it's time to go to the next city. And I would wander to the train station, and I would find somebody random, have a nice chat with them. And when I absolutely don't have anything else to do, I'll take the train and go to the next city. And I thought to myself, this is amazing. If I have a flight to catch, I keep looking at my flight tickets days in advance. What if I miss it? I'm all stressed out because there's one flight, and if I miss it, I may not be able to make it to the city in a day or two, and I'm absolutely stressed out. But here there's a train that leaves every 30 minutes. If I don't take this train, I can take the next one, not a big deal. And all of a sudden, the way I thought about this was very different. I was very relaxed. I was able to focus on what I want to do rather than just taking the train or traveling to another city. So in other words, there's a train that's leaving every 6 months. You can leave on any of those trains. If your feature is ready now, you can get on the September train. If your feature is not ready right now, but it'll be ready soon, you can get on the March train. And you get to decide if you want to take the March train or the September train. How does that change your way of developing software? And I would say that's brilliant. Because now you're not trying to hurry up or slow down to meet a deadline which is artificially created to synchronize with other features of the language. And I call this the brilliance of releasing software. They completely decoupled what goes into a release from having the release. And you get to decide what goes into a release when you are ready to release it. And what is this called? Maturity. It's amazing to see that in our industry, isn't it? Because you're not forced to do things because somebody told you that's what we will do. You get to choose when it's the right time. You're working hard on this feature, you think it's ready, go for it. You don't have to wait for other things. Besides, the features get released as a preview feature. People get to use it. They give you a feedback, and based on that, you make changes. Has that happened? Quite a few times already. The text block feature is an evidence of that, for example. In more recent release, in Java 19, the syntax for guarded pattern matching is different. We use a when instead of an ampersand. And again, going back to switch, they decided to use the yield as a way to exit off a switch. Every one of those changes in the language came from active use and feedback. So as a result, there's a train that leaves every 6 months, and they can take any one of those trains, and that really makes a huge difference. And so Java is being released on a 6-month cycle, but it's not being developed on a 6-month cycle. And this really comes back to the true agility that we all only think about and wish for, but they took a very bold step to make Java really agile in that regard. And as a result, there is a 6-month release cycle, and before the time, if I ask people, what is the thing that comes to your mind when I say Java 8? Just think about it in your own mind. When I say Java 8, what are you thinking? I know some of you thought about Lambda expressions. I know some of you thought about streams. But how many of you truly, at this moment, thought of completable future? Yeah, not a single person, isn't it? Is that not important? It's actually quite important, quite significant. But why did I not? I wrote an entire book on Java 8 functional programming, never even mentioned the word completable future in it. But why? Because when you have so many features being released, there's only so much you can focus upon. But now we have these bite-sized improvements. You get to enjoy one little feature at a time. You can catch up with it on a 6-month cycle. You don't have to face this water hose where everything is poured on you and you're trying to really struggle. And that is an amazing journey, if you will, that we can take. For example, one of the things about Java is moving, I would say, in a very pragmatic and practical phase. Java developers are not interested in changing the language for the sake of changing. They're asking 3 important questions. The first question they're asking is, will this new feature that we are considering in Java, would it really help the Java developers? Is this something they would benefit from in a fundamental way? That's the first question they ask. The second question is this feasible to implement it without breaking things that exist? Backward compatibility is a very interesting thought. When you look at programming languages, there are languages that really work hard to provide backward compatibility. There are languages that don't. They change things. And the people using the language, maybe a small community, they get really excited. They say, whoa, that's great. We can change everything now. But that's not going to work for a lot of people. Java simply has no luxury to do it. Why? The reason is, if you look at a lot of other languages, with all respect, I don't mean any disrespect to any of those languages. But when you look at a lot of other languages, the user community is much smaller, relatively speaking, compared to Java. Java as a language has more than 10 million programmers and thousands of enterprises that use the language. Well, think about it for a minute. If you have 10 million users, and out of the 10 million users, 1 million users know where you live, you have to make decisions differently, isn't it? So as a result, they don't have the luxury to make changes the way a lot of other languages do. But the story of backward compatibility is this. Languages that really want to provide backward compatibility are doomed. And languages that don't provide backward compatibility are also doomed. So this is a path of no return. You're doomed if you do and you're doomed if you don't. And it's a question of choosing which way you want to get doomed. And Java decided they will really provide backward compatibility, and that is a lot of work, a lot of effort. So that's the second thing they consider. Is it useful? Is it feasible? And the third thing they ask is, what else will this make it hard in the future to implement? Are there features that are going to get really hard to bring in if we go back and implement these features? A case in point, they wanted to really implement the ability to do raw string. But 3 weeks before the release of raw string, they took the bold step and removed it. And people blogged about it, people talked about it, people wrote tutorials about it, and they all like, whoa, what happened to this feature? It's gone. And they said, well, we learned from the experience. We learned that this needs to be really reworked if we really want to support the next use case we aim, which is text blocks, which is amazing. So I'm sure we all have worked with this in the past. For example, I could say message plus equal to, I could say, hello there, for example. Then you say message plus equal to, how are you? And of course, then we go on and say message plus equal to, and we can write more after this, and we can keep going. Every single one of us have written this code, isn't it? But it's not a one that you're proud about. Do you care to put that on your resume? I've got 7 years of experience putting plus equals in the code, right? No, this is the code you hide from humanity. You never want anyone to know about it. If you work from home and you got small children at home, you close the lid very quickly when they walk in, because they look at this and say, that's what you do for a living? And that's pretty dangerous, isn't it? I mean, I really wish my elders told me this. When I was a little young, when my children were really small, I would put them on my lap. And while I'm working, they would be sitting and just playing. And I never thought about it. But as time went on, the children are just not playing. They are actually watching the code you are writing as well. And one day, one of my children said, "Dad, don't worry about it. I will grow up and take care of you. You don't have to do this anymore." Well, that's what happens when we write poor quality code, isn't it? That's not a code we want to show anybody. Well, good news, we don't have to because of text blocks. We can simply write a nice little string, a multi-line string. We don't have to be escaping over and over and over. And we can also put many different things inside of it without much effort at all. And that becomes incredibly easy to write, as we can see. And that becomes really a nice little text block we can write. So, and of course, this concept is called the here docs in other languages. And I always look out for what's the innovation in here. And to me, the innovation is not just they brought in text blocks because that was available in other languages. I've used here docs in other languages, and I'll be honest about it. It's a nice feature, but occasionally it would misbehave. And it'll cost me about 15, 20 minutes of my life. And I'm not very happy when that happens. I would sit there and say, "Please work. Please line this up properly." And I'm like, "What's going on here? Why wouldn't this work?" And you're deleting code and building it back together, and you're just waiting to please this compiler or the runtime. Well, the innovation of text blocks is, when you look at this particular code example, for instance, the indentation that you see right here, those are called incidental indentations. They simply strip it out, knowing you're just following a convention. These indentations, of course, are the essential indentation. So the compiler is really smart, where the compiler thinks like you and makes it easier for you to get the code done. That becomes a lot easier. Similarly, some of the changes that I'm really, really excited about. For example, let's say I'm going to call a function called process, and I'm going to pass a 1, or call a process and send a hello to it, like so. And in this case, I'm going to say public static, let's say string, a process, which takes an object as an input. I just want to process some set of messages that are flowing through, let's say. Well, in this case, I'm going to simply return, let's say, whatever to start with. I'm not interested in processing that right now, so I'm just going to say whatever. But in this case, I say if the input is an instance of, let's say in this case, an integer, I'm going to simply return from this return, let's say, got a number. Well, that's a good step. I can process if it's a number, do some processing. But on the other hand, if input, let's say, is an instance of, oh, what if it's a string? I can return from this over here. I can say, hey, got a string. Well, a good first step, if you will. So I can say got a string and return that value. But then I say, I want to say of length. And I want to say what the length really is. But how do I know what the length is? I'll say int length is equal to input.length, and I want to call that method. Well, as you know, if you try to write that code, unfortunately, what does the compiler do? It promptly tells you method length, variable input of type object, error. Let's think about this for a minute. Imagine you're leaving the building one evening and you see a good colleague of yours and say, "Hey, where are you going?" And your colleague says, "You know that movie I've been waiting to watch? I'm finally going to see it today." You said, "Awesome, have fun time." The next morning you see them at breakfast and you ask them, "Did you go to the movie yesterday?" They say, "Yes, I did." And you say, "How was it?" And they say, "How was what?" And you're going to stare at them and say, "Really?" You're not going to have much of a conversation with this person, right? Because you said, "Did you go to the movie?" They said, "Yes." You said, "How was it?" And they say, "How was what?" Well, we as humans carry a context, carry a conversation. And if somebody doesn't, there's not much of a conversation to have at that point. Now look at what the compiler did to us. Compiler, is the input a string? Yes, it is. What's the length of what? And you're like, really? Seriously? Now they call it casting. I call it punishment. Because at some point you ask the question, do you work for the compiler or does the compiler work for you? In this case, you're working for the compiler. It says, how is it going? I'm working. Work harder. I'll check on you after lunch. And now you're spending all this effort writing the code. That's no fun. But you don't have to, thankfully. When the language matures, we become more productive. So in this case, you can go to this and say stir. And you can come back and say stir. And the compiler is quite happy with this. It says got a string of length 5. So we are able to specify a casting as part of the instance of check. So basically in this case we said, hey, if it is an instance of input, a string, give me a reference called stir, I can simply use it. Now of course they call, other languages like Groovy and Kotlin call this smart casting. Java calls it pattern matching with instance of. The reason they call it pattern matching with instance of is this blooms into a full-fledged pattern matching syntax, and as a result, it becomes easy to do not only switch over constants, you can do switch over objects and types of objects as well, and that really reduces the verbosity in the code. And that's an amazing journey because it reduces the noise in the code and it helps us to really write less code, which is less error prone and makes us more productive as well, and that's a big change. In a similar way, there are several things that every single version of Java, almost, is bringing to the table where we can get better at writing the code. So rather than having to really struggle through the language in one big release, we are able to incrementally evolve and adapt as the language is evolving and adapting. And all of a sudden, it feels like the language has not left us behind. When you're a corporate developer, enterprise developer, writing the language because that serves really well in production, you don't have to feel left behind. The language is growing and moving. And those interesting features that often we talk about in other languages are not just things that are available for others, it's things we could use for ourselves as well, and that becomes really powerful for us to embrace and move on. And as a result, we are able to work in a very powerful environment, but at the same time work very powerfully with it as well, and that becomes absolutely phenomenal. A case in point, for example, is one of the things I really enjoy in Java is this concept of records. And records are pretty powerful in that we've all been writing code for a long time, but the code can become really verbose and error-prone at the same time. For example, let's say, for instance, I want to create a class which is going to be representing a stock trade. So I'm going to say, here's a stock trade. I'm going to say private string, let's say ticker. Then I'm going to say private int, and I'm going to say a price as well. Well, that's great. We defined a ticker and a price. That's awesome. But then you say, are we done? No, we're just getting started. We then need to say public stock, and we can say string ticker and int price, and of course go through the ceremony of saying this dot ticker is equal to ticker, and of course this dot price equal to a price as well. And then once we write this, what are we going to do? And of course, you may make a decision at this point to say, that's a final, and that's a final too, good for us. But then what do we do? And one of the things I always think about is, when it comes to programming languages, what are the defaults of a language? I want languages to give me safe defaults, not unsafe defaults. When a language gives us safe defaults, we are able to write code more productively, and it's less error-prone. When a language offers defaults that are not safe, we have to work hard to keep saying these kinds of things. I need to say final. Why? Because a language chooses not to make it final. But when you program in languages like Haskell or Kotlin or Scala, what kind of defaults do they choose? That's something to think about. So in this case, of course, we also write a public string, get ticker, where it's going to return the ticker. Then, of course, you may have to write the get price function. And you say, oh, come on, Venkat, that's not true. I never write those functions. I define the fields, and then I gently right-click on it. And before I can blink my eyes, the IDE vomits the rest of the code. And now you have to live with that vomit. And that vomit is an unerasable ink. And you live with it forever, and it gets smelly over time. And then you realize, but I still have to write the equals with the toString method. Oh my God, you forgot the hash code method. More error in the code. Why do we have to deal with it? Instead, you can simply say, hey, I have a record called stock, and I'm going to get rid of a lot of these noise. And I'm going to simply say, here's a ticker string, and here is a price, and I am done. And I can remove all that code that we would have otherwise had generated for us. So as a result, in this particular case, as you can see, we don't need to be writing as much code. So we can say stock over here is equal to new stock, whatever you want to call this. Let's say Goog and 100 or whatever you want to create, and you say stock. Well, records actually offer buy one, get 5 free offer. How cool that is. You write a record, but you got 5 things for free: a constructor, a toString method, a equals, a hash code, and a getter for that as well, for the properties of the components, as they call it. And the toString method is a little bit more intelligent, gives you some relevant details, but you can override it if you really wanted to, and that makes life a lot easier. But not only that, you cannot mutate a property that you create in this case. You cannot mutate a ticker or a price. So you got really nice immutability built into it as well, which makes the code a lot more safer when we write it. So as a result, these things take us in the right direction. Not to mention, one of my other favorite features is the sealed interfaces and sealed classes. Sealed interface and sealed classes is phenomenal because it gives us a way to model in a way that we can convey our design criteria more effectively. So in a way, you could say Java 8 was functional programming capabilities. Well, guess what? Java says there's more improvement in object-oriented programming. We're going to make your life better by providing records. We're going to make your life better to do OO programming, again, by providing sealed classes in sealed interfaces. So not only can you do better OO, but you can also do better programming in object-oriented style. But that is not to say, if you look a little deeper, one thing, if you ask me, what are the changes in Java that are absolutely significant? Sure, Java 5 was exciting. It gave us generics and a few other things. So that was really, maybe we should say, significant. Java 8 was life-changing, in my opinion, because you could do functional programming with Java 8. Java 9 was significant in terms of bringing modularity, even though several of us have used it in different degrees. But I would say the next big thing in Java is Java 19. And that is probably more significant, honestly, in my opinion, than even Java 8, because it fundamentally changes how we do asynchronous programming. With the concept of virtual threads, you are able to write non-blocking calls in almost an effortless manner. And this is where I really admire the power the programming languages and capabilities give us. I'm not going to show you examples of that here today, but I'm going to just talk about why I'm so excited about it. So that way you can be as excited about what's happening in Java 19 as I am. But let's step back for a minute. Suppose you're writing programs and you're using single thread. Imagine this was Java 7 or Java 6, and you're writing these single-threaded programs. How do you know you're working on a single-threaded application? I'll tell you how you clearly know. You go to work and people smile at each other. That's how you know it's a single-threaded application. And one day somebody says, we got to improve performance. Let's put multi-threads in here. That's the day, the last day there was joy at work. And everybody is grumpy because we have written code that's unmaintainable. We're fixing bugs. And late in the night, one night, you're tired because you just could not keep up with these bugs in the multi-threaded code. So while you're fixing your bug, you applied for the next job. That's called concurrency. And you said, no, I'm done, right? So in the past, what happened? This is what happened, right? The structure of sequential imperative style code was very different from the structure of a parallel imperative style code. The imperative style code, sequential code you wrote was beautiful. Okay, almost. At least we can believe it was, right? You could see it. You could reason with it. You could say, here's what is happening. And somebody put some threads into it. And they put a few locks into it. They put a few synchronize into it. Now you cannot recognize it. The code turned into a monster in front of you. And you look at this and say, back in time, how beautiful this code was. And occasionally, you go to the version control and take a look at the old code as it was, just to feel better. That's the problem, code that is unmaintainable. Well, with Java 8, two things happened, right? The first is the structure of sequential functional style code is the same as the structure of parallel functional style code. Thanks to, of course, Java streams and, of course, Lambda expressions. The structure of sequential functional style code was exactly the same as the structure of parallel functional style code. You could write the code sequentially, change a stream to parallel stream, or just insert a parallel, and you got multi-threading on it, cautiously, of course, but you didn't have to change the structure of the code. You can reason the code sequentially, and you can carry that reasoning to parallel execution very nicely. Not only that, we saw one more thing. The structure of synchronous functional style code, let's try this again. So the structure of functional sequential style code, functional style, synchronous functional style code is the same as the structure of asynchronous functional style code. Of course, thanks to completable future. So we can write the same exact code that can run synchronously and without much effort at all, make it asynchronous. But notice the trend in here, unfortunately. If you want to buy into these flexibilities, you have to turn in your passport, sell your house, and migrate to this unknown world of different style of programming. You could no longer program in imperative style. You had to program in functional style. Don't get me wrong, I'm a fan of functional style of programming. But functional style is great as long as you don't deal with impurity, side effects, and that evil exceptions. The minute exceptions creep in and you have to handle multiple levels of exception, what just happened? The functional code becomes dysfunctional. It becomes horrible to write and maintain it. And we struggle with it. And now we are like, gosh, what's wrong here? I thought this was a great way of writing code, but there is limits to everything we do. And this is what blows my mind. Finally, the structure of, you can say, the structure of synchronous imperative style code is now the same as the structure of asynchronous imperative style code, thanks to Project Loom, virtual threads. So this really brings this into a closed circuit. If you're programming imperatively, not because you can't program otherwise, it's because that's the right thing to do. Because you have a nested exceptions you have to deal with. Then what this gives you is the ability to really bring them all together. And it says you can write your synchronous code using imperative style, and you can make that same exact structure work for asynchronous as well. And the virtual thread says, I'll be non-blocking for you behind the scenes. When a task is blocked, a thread is not blocked. Think of this like a waiter in a good restaurant. You're sitting around in the table, the waiter comes along and says, what would you like to drink? You say, I'm not sure what I'm in mood for. What do you have? And the waiter gives you a list of things you could order. And you say, I'm still not sure. I'm thinking, what will a terrible waiter do? Sit around and say, what do you want? Let's talk about it. But that's not efficient. The other tables are waiting in the meantime, and the restaurant is not going to make profit doing so. A good waiter says, why don't you think about it? I'll be right back, and swings by to help other tables. What if your threads are not held hostage when a task is blocked, where it can be truly non-blocking? And as a result, your coding becomes simpler, but you get performance and throughput behind the scene. The structure is the same, but the semantics is different. And you're able to get that benefit of just flipping a switch, thread, virtual thread. And to me, that's why I feel this is going to be huge. This is going to be huge because it's going to fundamentally change the way we build our servers. It's going to be huge because it's going to fundamentally change how we build large-scale applications, microservices, enterprise systems. In every aspect of what we do, it's going to make a change. So if you ask me what I'm excited the most in Java, I would have said that was Java 8. But now I would say that's really Java 19. And the reason is you can see the fundamental change that's happening here in terms of the capability it's offering. Java 8 made a substantial difference in how we program the applications. Java 19 is going to make a substantial difference in how we program our microservices, how we program our systems and servers. And to me, that's one of the reasons why this is exciting. So a fundamental shift in the paradigm is a lot more powerful than a shift in syntax. And to me, this is not a syntactical change, it's a semantical change. It's a paradigm change. And I think that's what is going to benefit. We're going to take years to really realize this benefit, but it's also going to be very long-lasting. So that's one of the reasons why I'm truly excited about this. So every step of the way, Java has consistently shown the amazing things we can do with the language, but also with the infrastructure, the ecosystem. And I think that is absolutely phenomenal. And that's why I respect the changes that are happening in the language, is because they're very thorough about it. And not only they do these changes, but they're driving these changes based on the feedback cycles. So many people can talk about being agile, but it's so refreshing to see that Java is being agile. They're not saying we want to be agile, they're just quietly being agile. So that to me is absolutely refreshing. It's very rewarding, it's enjoyable, and I hope it is for you as well. Thank you so much. Hope that was useful.